Hello, in this video, we are going to help people who are struggling with the ordinary differential equation, especially in separation of the variables. This is the first video of the tutorials of differential equations. In this video, we are going to solve two or three examples about the separation of the variables. This is one of the easiest differential equation topics. If you are struggling with this, watch it closely, and in next videos we are going to cover all differential equation topics, but you should be familiar with this kind of easy methods in order to solve more complex methods. In this video, I am not covering some lectures about the separation of the variables, just we will fully focus on the examples. First example is, let's say, we have example 1. In this example, we have dy over dx is equal to x squared over y squared. And we have the values, initial values y1 is equal to 2. So in order to solve this question easily, we should move every y next to dy and every x is next to dx. So in order to do that, we can do cross multiplication in this example. So we will have y squared dy is equal to x squared dx. So we can integrate both parts. So we integrate both parts. And as you know, the hint, like in order to integrate any x to the power of n, we have x to the power of n plus 1 over n plus 1. So in order to integrate this, we will have y cubed divided by 3 is equal to x cubed divided by 3 plus c. C is constant, and that's why we have here initial value in order to find what's value of this c. So we can multiply every part by 3. So we'll have y cubed is equal to x cubed plus 3c. So from this, we can find third cube of both sides. So in order to find the whole value of y, so we have y is equal to under the third cube of x cube plus c. So how we can find c here? So we have values of both sides. So this is our initial value. So we put for one this and for two this. So we have from this we have 2 is equal to third cube root, like or cube root of 1 plus c. So if you find the cube of both sides, we have 8 is equal to 1 plus c and c is equal to 7. So our y is this one. So we have y is equal to under the cube root x cubed plus 7. That's our value. So this is the first example. It's a little bit easier. So let's move to the next question. So let's look at the example 2. So we have y prime is equal to xy. So in this example, we have initial value for this y0 is equal to 5. The, the previous problem we have dy over dx, but in here we have y prime. So some students are struggling to get what's going on here. So we should keep it always in mind that y prime is always equal to dy over dx. We can put it here, not. So we just write again dy over dx is equal to xy. So what we can do in this example, I will explain easy. So I just multiply every part by dx. So we have dy is equal to x times y times dx. After that, we should move this y under the root, under the dy. So we have dy over y is equal to x times dx. So in order to make it a little bit simpler, so we can write 1 over y times dy is equal to x times dx. So you know the next move. Next move is integrate both parts. In previous example, you know that the integration of x is just x squared divided by 2 plus c. But what about this one? So as you know that integral of 1 over x is equal to ln x. So here 1 over y, integrate of 1 over y is ln y. So what we can do this in this example. So you know that when we have logarithm a to the power of b is equal to x, so it means that a to the power of x is equal to b. From this example, so ln means that logarithm e to the power of y, e y is equal to this x squared divided by 2 plus c, or we can write e in both parts. So we have e, so from this one we can see that y is equal to e to the power of, so we can see that y is equal to e to the power of x squared divided by 2 plus c. So we have e 1 over 2x squared plus c. So we can write it, make it more easy. This part is just not so we can, if you don't want to look at it, don't look at it. So we can write like this. So we can write it separately. So e to the power 1 over 2x squared times e to the power of c. So in order to find c, we should use this initial value. So we have 5 is equal to 5 is equal to e to the power of 1 over 2 times 0 times e to the power of c. Uh, then we have, this is 1. So we have 5 is equal to e to the power of c. And we can see any other move here. So we can even like for e to the power of c, we again can say that this is another constant because e to the power of c is a number, like e is approximately 2.71. So if it's like constant, so e to the power is again constant. So we can say that c is equal to 5 because we replace one constant with another constant. So we have y is equal to 5 times e to the power of 1 over 2 x squared. So this is value of y. And let's look at the third example in this equation, and we will finish this separation of variables. So we have, again, we are given with the dy over dx is equal to y squared plus 1. So again, we can write everything, we can multiply everything by dx. So we have dy is equal to y squared plus 1 dx. But we don't have any x in this example, so what we're gonna do? First of all, we move every y under the dy, so we have y squared plus 1. And we have here 1 times dx. So if we don't have anything, so it means that there is a 1. So we just write like this. So as you are familiar with the table of integration, you know that this is arctangent y. So we can write like this. So this is equal to arctangent y. So we can have tangent to the power of negative 1. Y is equal to, and we have, but if we have 1, so it means that the integration of this is x because the prime derivative of the 1 derivative of x is 1. So we have x plus c here. So we can write, if we are familiar with the integration or with trigonometric integration or another things, if you write like this, tangent and tangent to the power of minus 1, y is equal to tangent to the power of x plus c. What's that? So if we have function, and inverse of the function. And if you make it a composite function between function and its inverse, it's always gives us the value of x, or like value of, like if we have something like this f and inside of this, so it's always gives us x. So here we get this one. So we have y is equal to tangent x plus c. And also, I forget to write our initial value. It says y1 is equal to 0. So we put like 0 is equal to, here we have 0 is equal to tangent 1 plus c. And the tangent 0 gives us 0. So from the trigonometric table, that sine tangent is equal to sine over cosine. So if it is the 0, so sine 0 is 0. So that gives us 0. So we have 0 is equal to, so 1 plus c, because this part can be 0. So we have c is equal to -1. So our final value is y is equal to tangent x minus 1. That's end of the video for separation of the variables. If you like this video, let's see you in my next video. We will use substitution method to solve ordinary differential equation.